So then dimension length is 243, diameter is 90.7.
How do you get to that window?
Cutting length.
Ok, bon, c'est différent si tu tiens que c'est une note.
C'est différent? Non, valide, accept this.
Ah, ok, that's why.
But first, did you set the, let me check. Click on the first one, no, the top one. Okay. Tool number is 11. This is the most important. Okay, now dimensions. Go on the dimensions. Tu peux m'en mesurer la hauteur de coupe? Peut-être par là.
30.8.
Cutting length is 30.8.
Mais quoi,
Total length is 243.
Attends, plus qu'on va utiliser le. Il faudrait plutôt utiliser juste la partie ici.
Non, en fait.
Si on veut pas aller, au complet.
Ouais, mais on ne fera jamais de plongée directe, donc c'est pour pouvoir travailler sur le côté, tout ça. Donc, je mets la longueur totale. Cone is 35. On peut mesurer la partie.
43, 9.7.
La partie du bas, là, la plus. Prends peut-être l'intermédiaire, hein, dimension.
Intermédiaire, tu sais.
Celle-là, ouais. Non, un peu plus haut, juste au-dessus. Celle-là, ouais.
Ici, là.
Hein. Oui, il faut non, là, surtout le diamètre. Hein.
Le diamètre ici. 40.
La longueur depuis le haut de la fraise jusqu'au bas du. On va prendre la longueur de ici jusqu'au début là, du rayon. Là. Après on définira le reste. In fact, we can define two loader and two different two loader.
C'est au début du rayon ou la partie plate?
Non, la rayonnée, avant le début de la rayonnée. Ouais, voilà.
Ah, ok, pour pas aller trop.
Ouais.
Vas-y avec 140.
Okay, so we define the lower part with the bigger diameter here and with the length until we reach the beginning of the radius, and then we define the big dimension, which is c'est combien là ici ouais.
Le diamètre?
Ouais.
On a 75.
Et le dernier, on rafraîchit, ça va faire 37,2 juste pour rigoler. Okay, why we do this? Because if you want to plunge in a pocket with this kind of tool, you need to know how deep you can go without touching on the tool holder. Well, in this case, it's not important because the diameter of the diamond is bigger than this. So.
Right. Yeah.
But sometimes when you have a small tool, it's really important to define the tool holder to make sure you don't hit the stone with the tool holder.
Right.
Okay. So now we can go on the watering. So we select inside and outside. It's not important on pilot to put it, but if you don't set any water, you will say the tool is not well defined, because as you see, we defined the watering here, and this is what manages the watering. Okay.
So inside watering is
So
1.
yeah, but even if you don't put anything,
It does work. Okay.
okay.
Il n'y a pas les valeurs pour la mesure.
Comment?
Il n'y a pas les valeurs de mesure.
C'est-à-dire
Ben, tu sais, quand on mesure jusqu'à un certain point, après ça rejette l'outil. Il n'y a pas de diamètre. Ben, dans ce
le
cas-là,
mini,
c'est quoi?
ouais, non, en fait,
Ça va être la longueur max.
ici c'est. Ouais, je sais pas pourquoi j'ai le symbole au diamètre. Hein. C'est bizarre. Hein. Ok, so we're going here and on pilot. Okay, so can accept this.
Well, there was a section here about rotation direction. It was defaulted as clockwise.
Also, it's not used on the machine. So one more time, pilot is normally done to manage all kind of machines, but the TCs are able to work without any interface. You can do AB and so on. So that's why the rotation speed, watering, and rotation direction is managed on the machine itself. So this is just information. But if you have any full CNC machine, just working center, then everything is managed over there, and you cannot do anything from the machine itself. If you want to do something with the machine without the computer. Okay. Good. So now we can reopen the yesterday project.
Feed rate. So this milling tool has like a range, like 1 to 5, I think, or something like that for the speed.
Stubbing wheel, c'est pour ça que stubbing, je sais pas c'est quoi la traduction exacte.
Ah,
That's the one that we just loaded.
okay. What did it say?
So there's 1 to 5 millimeters of removal.
Ah, okay.
Right, it will be
So
different with the
4,500
material
RPM.
and RPM.
And feed rate is 400 to 800 millimeters per minute.
Yeah.
That's where, like, on here, we were
But
saying
on what kind of material?
Right.
granite or engineered stone.
So for something harder than that.
Yes.
So I guess we can go too
So we could say
faster
1,000.
than that.
Yeah, but not 2,000 like we would with the disc.
Does the RPM change between this tool and the cutting and the blade? Like I know this is 4,500 RPM.
So in fact the blade is supposed to run between 30 meters per second for the granite to 50 or even 60 meters per second for the limestone. Okay, at the moment, yesterday I saw the blade was defined at 52, I think. The blade is defined at 53 meters per second, which with the big diameter makes close to 1000 RPM.
Okay, so quite a bit slower.
And if you are looking on the milling tool, you see 4000 RPM is only 21 meters per second because it's a small tool. So normally we should maybe go higher than that, but it's like a car engine. If you all the time run your engine full RPM, then the motor will not last long.
Okay.
So
What,
that's
what's What's the
4,000 is okay for this kind of tool.
What's the maximum RPM for?
6,000.
6,000, okay.
So
And so
for
that's
the
maybe
smaller
for a
tool,
smaller-
you will use 6,000. yeah.
Okay. Understood, thank you.
Okay, so yesterday we stopped at this one. Okay. So now we want to make the finish with that tool on the two sides. So there is many options in 2D, 3D menu. So yesterday we stayed on Thibault operation, and now we go on 2D, 3D, which is the regular part of the software, because milling is something we do in all kind of industries. So we have many options here. You can see this is all of them are different kind of toolpaths. We can say from this position to the end, it is really 3D machining toolpath, and from this to the left, it's only 2D and a half machining toolpath. Okay, so when you are doing the roofing, you will start all the time on 3D, because roofing